Ladies and gentlemen, please put your hands together for Sujeeth Pai, Country Sales Manager, National Instruments, India.
Good morning and welcome to NIDays 2012, our annual Graphical System Design Conference. It's great to see all of you here. We've got a record registration this year of about 2,000 people. So we look forward to welcoming more of you all as the day progresses and spending time with you all. The theme of our conference this year is celebrating the success of graphical system design in India. So people from NI as well as our customers will be talking to you today about the different things that we've done at NI and how we've been able to use the graphical system design platform approach to come up with innovative solutions for problems and challenges that we face in our everyday lives. You know, before I can really talk to you about NI and what we do at NI, I think it's very important that we understand the impact of great engineering. As you know, we're all engineers. NI is a company founded by engineers and scientists for engineers and scientists, and we're all engineers and scientists here. If you look at any of the problems in our day-to-day lives, let me just take a few examples and say designing, testing, and producing systems. Engineers have a way of doing this faster and saving time, saving effort, saving money, and this creates wealth, this creates jobs for all of us. If you look at improving everyday life, the quality of life, be it detecting cancer at an earlier stage, or just ensuring that our cars are safer, or making sure that the chairs we sit on don't break. This again is something that comes out of engineering. We had Neelam last week and Sandy last week, so it's a reminder of the great force that nature has and things that natural disasters can do to us. So things like building earthquake-proof homes, early warning systems for tsunamis and tornadoes. All of these are the results and the impact of great engineering. So that's what all of us, all of you, and our companies do as engineers. The problem, though, is earlier we had Edison, we had Dr. Visvesvaraya, we had all these people that we could look up to, and that would remind us about the impact of great engineering. Today, you have Katrina Kaif and you have Saif Khan, but nobody really has a role model when it comes to engineering. Considering this, the Academy of Engineers in the US came out with these 14 great engineering challenges that are required for engineers to make the world a better place. If you just look at these challenges that are put out there for engineers, I think it's a reminder to ourselves and a reminder to all of the young students and the youth today that really all of the world's problems that exist can be solved by great engineering. If I just pick a few of these and talk about, say, clean water. We take it for granted today, but there are a lot of people suffering from improper or without having enough water to drink. And this is a problem that engineering can solve. It's not something that an investment bank can solve, right? Similarly, energy, clean energy. So we are running on fossil fuel today, but all the efforts that go into making sure that we continue to have energy in the future is dependent on great engineering. So really, it is important that we understand and we spread this message that it is very, very important that engineers realize the impact that they can have on society and on making this world a better place to live in. Considering engineering is so important, what is it that we do at NI? So something that we strongly believe at NI is that tools should not limit scientific discovery. So what we do as a company is provide engineers and scientists with tools that accelerate productivity, innovation, and discovery. We will talk about it as the day progresses. We'll talk about specific cases. So I'd just like to start off by giving you a quick overview of National Instruments as a company. We're a global company set up in 1976. We're headquartered in Austin, Texas. We've been around for about 35 years, and we have a very, very strong track record of growth and profitability. In fact, last year, we're very proud to say that we hit $1 billion in sales. So that was a big landmark for us. Another thing about us is that we're a very, very diverse company. We're a products company, and we equip engineers and scientists from all different fields. So, we do not get more than 15% of our revenue from a single product line, and we don't have a single customer that contributes more than 4% of our revenue. So we're there to ensure that scientists all over the world in every field, in every discipline, can innovate and can accelerate their innovations using our technology. So what do we do, and how do we do it? So this is our mission. We want to make sure that we equip engineers and scientists with these tools. So the question is, what is it that we exactly do? Now, if you go back in time and you look at the great innovators like Edison, really systems were very, very simple then. And they used a drawing board, they used just a drawing board, they used spanners, they used wires, and they were able to rig up their systems to experiment and create systems that they required. When you look at systems today, they're a lot more complex. If you just take something as simple as a phone, today you have a GPS in it, you have a video camera in it, you can do everything with it as well as make calls, not just a phone. So any system that you need to create today, you need to acquire real-world signals, you need to process these signals, as well as you need to send out signals. Right? So at National Instruments, we offer a very, very modular hardware combined with a powerful graphical software with which we have a platform through which you can acquire, process, and process signals. So this platform-based approach for design, test, and embedded is called graphical system design. Now, at the center of graphical system design is this very powerful software of ours, which is called LabVIEW. LabVIEW was first introduced in 1986. It revolutionized the way engineers and scientists created their systems. Now, as engineers, we're wired and taught to think in terms of block diagrams. So LabVIEW gives engineers and scientists the opportunity to create their system in LabVIEW through block diagrams, and then realize the actual physical system by porting this onto National Instruments hardware. So LabVIEW seamlessly ties with our hardware. So by just taking a block diagram, taking an idea, putting this onto LabVIEW, and then putting this onto the NI platform, you have a very, very easy way of prototyping and deploying embedded systems, test systems, control systems. So with this, I'd like to switch to India. India is a very, very diverse economy. I've just spoken to you about what NI does globally as a company, but I want to spend some time on India specifically and how important engineering is in India today. Now, we're a diverse economy. We're growing at a healthy rate. The economists keep changing this forecast a little bit here and there, but we're at around 8%, which is a very, very healthy growth rate. We have a great mix of small, medium, and large-scale enterprises. We are the fastest growing automotive market in the world. Defense, there's about $35 billion that's going to be spent on defense, and every day in the news you hear about foreign companies wanting to tie up in the offset program and enter India. So there is a lot going on in India in terms of engineering, science, defense, and innovation. So I'd like to take this time, to talk to you about a few applications that we've done in India. Throughout the day, we'll have some of our customers come and talk about specific things that they've done. So without getting into those areas, I want to quickly give you a run-through on what are the different areas that we touch. There's research, there's defense, there's automotive, I'm going to take you to just a few of these examples for you to understand what we do as a company. Take research labs, for instance. India has, we have the DRDO lab, we do some great research work there, and the work of these labs is to make sure that we're pushing boundaries and doing things better day by day. Take, for example, NIOT. NIOT has been able to create an underwater trawler that is able to explore, so we're able to do undersea exploration at depths up to 4,800 meters, right? So that's close to 5 kilometers under the sea that we're able to go get minerals, explore minerals, and see how you can improve life. Now, the entire control system for this is based on the NI compact wheel. So it's NI there that's enabling us to control this underwater robot 5 kilometers under the sea to make sure that it goes and picks up things that will help us in discovering new minerals. Similarly, we're making the life of our soldiers safer. So we have at CBRDE, there is an autonomous tank that is made. Again, the drive-by-wire system for this is built on an NI platform. Right? Telemetry receiver. So we've also been able to take a telemetry receiver that was traditionally built on a rack and stack system. We've been able to reduce this from a 19-inch rack to a single slot system. What we've also been able to do mainly is the fact that the amount of time that it took just to maintain and upkeep this system on a yearly basis is the amount of time that we have taken to develop this system. So we've been able to really accelerate the time that it's taken to develop the system, at the same time reducing the space required. And in a lot of cases, these are portable systems, so space is a big constraint. Aerospace, making travel safer for both civilians as well as our defense forces. HAL, right? HAL is one of our premier aerospace institutions that that manufactures the LCA, it manufactures helicopters, and one of the things that we do at HAL is testing of the gearboxes that go into the helicopters. So the entire gearbox test facility is based on National Instruments hardware and software. GTRE, it's the only institute in India which is doing research on gas turbines. The Kaveri engine has, the flying test bed has been successfully certified, so we are gaining some wins there in terms of developing our own gas turbine. And again, it's important that these gas turbines are tested on the ground to ensure that people who do test flights do not put their lives in danger. So NI is there making sure that these turbines are well tested on the ground before we even take them off the ground. Aircraft simulators at ADA. So the LCA is something that's been very successful for us. There are different versions of the LCA that India is working on. And again, we're very proud to say that we are associated with making the simulators here to test the different subcomponents that go into the aircraft. Now, when you make an aircraft, there are different groups working on different subsystems. And to test each subsystem, you need the rest of the aircraft to be available. A lot of times, this is not possible because the development is happening in parallel. It's also not possible because safety is a big concern. So what we do is simulate the entire aircraft so that different subcomponents can be tested as if they're working in a real aircraft. Right? Wind tunnel instrumentation. So the biggest wind tunnel in India is at ISRO, and this is instrumented using National Instruments hardware and software. Again, automotive. I just read yesterday that a lot of the European automotive manufacturers are coming into India to try and make up for lost ground in Europe. The sales of automobiles in Europe have reached 1993 levels, right? So it means that they're pretty much 20 years behind in terms of the market. So they need to make this up. They've invested, they need to make up, they need to get their numbers, and they're looking at India to get these numbers. It is the fastest growing market. So be it the Indian car manufacturers, be it the global automotive players who are coming into India, if you want to sell in India, the best way to do it is to make these products in India, because that's what gives them a cost advantage. Considering this, there are a lot of these players in India, and National Instruments again is in there helping them with in-vehicle data acquisition, testing for components that are made components that are made for these vehicles, testing radios specifically made for India, testing the navigation systems made for India. So, we are here to make sure that these automobile companies are able to do what they want as well. So these were just a few areas that I wanted to throw out there to make sure you understand the different areas that we work on. We will get into specifics as a few applications will be showcased during the course of this day. What we do though is provide products. We are a product company, and everything that I've spoken to you about right now is using National Instruments products. But as an engineer, when you have an application that you want to do, you may want a complete integrated solution. You may have the algorithm, but you may not have the time to develop the complete integrated solution with the mechanicals, with the wiring, etc. For this reason, we've also developed in India our partners. So we have local partners in India that we've started developing from the time we came into India. Specifically, we've got Captronic Systems that started as a one-person company in 1998. Today, they have over 100 people. Similarly, we have DigiLogic, very, very strong in the defense and aerospace segment. They're based out of Hyderabad. So we are developing these local partners so that we create an ecosystem to improve everyday life. At the same time, we also work with the big engineering services companies that are out there to provide a complete integrated solution with NI. In addition to this, one thing that I did talk about when we spoke about India is the fact that we have so many engineers. We have the largest engineering community in the world. This is a great number to have. We have more than 7 lakh engineers that graduate every year, but it's not a hidden fact that a small percentage of these engineers are employable. And we want to do our bit to make sure that we can improve the quality of education as well as improve research in education. With this in mind, we've set up about 18 Center of Excellences in different colleges in India. The idea of this is to make sure that students and professors can take ideas that they have in a book or idea that they have in papers and create this into real-world products. We give them the hardware, and we contribute in terms of the hardware and software platform. We contribute in terms of knowledge. We have our engineers who spend a lot of time with them. We have 18 of them right now. Few of them have been very successful. We've seen some products come out of these areas. So we will continue to do that to make sure that the level of research coming out of educational institutes in India goes up. At the same time, we also work with a lot of the other colleges that we feel need to improve their quality of education. We've set up LabVIEW academies. We go in there and try to help them teach better. We believe in this process called experiential learning, where using LabVIEW and our hardware, you can actually demonstrate and show a process, for example, instead of just doing it on your textbook. So this is an area where we focus as well. So, to summarize, we're here in India to empower Indians with GSD. We have our office here in Bangalore. We're headquartered in Bangalore. We also have an office in Delhi and in Pune. We have some great technical consultants pretty much in every city you can think of to come and help you with your applications, understand your problem, and help you solve great challenges using our platforms. Our managing director, Mr. Jairam Pillai, is not available today because of medical reasons. So on his behalf and all of us here at NI, we wish that you have a great conference, a productive conference today, and we look forward to interacting with a lot of you over the course of the day. Having said that, I'd like to introduce John Paskeret. He's the Vice President for Corporate Marketing and e-business at National Instruments. In his role of corporate marketing, he is responsible to deliver marketing strategies to over 40 countries, 40 branches. And in his role of e-business, he is responsible for the digital strategy of National Instruments. Before he was promoted, he served as the Vice President of Product Software Marketing, where he was responsible for the adoption of our application-based software.